got a request for graphing a quadratic function, also known as a parabola. So we're going to go ahead and do it given this equation right here. The first thing that I told you guys to do before finding the axis of symmetry is labeling A, B, and C, just so that it's easier later on when you go to plug everything in. So A is always the number in front of x squared, in this case that's going to be 1. B is always the number in front of in front of x, so in this case that's -4. And C is always the number that we add or subtract that does not have a variable attached to it, so in this case it's -5. So the formula for axis of symmetry is given to you in your notes. It is x equals -b over 2a. So what we're going to do is we're going to take this b value and this a value. We're going to go ahead and plug it into this equation right here. So plugging it in, I get x equals -b. My b value is -4. Make sure you keep your work very organized because this is -b. We plug in the value for b, so that means that negative is separate. So I'm going to plug in my b value, which is -4, over to a. My a value is 1. That's the number in front of x squared. So when I simplify this, I'm going to get 4 over 2, because a negative times a negative is a +4, and that's going to simplify to 2. But 2 is not the answer. X equals 2 is the axis of symmetry because it is an equation, not a number. So this is right here is a vertical line that goes through the x-axis at 2. That goes back to basic graphing lines. So I'm going to go ahead and draw just a dotted line here at x equals 2. Dotted or dashed. I like to put arrows on the end because that implies the line goes on forever, and it does. So the next thing that we found was the vertex. I've seen a lot of people labeled it as V. Go for it. I think it's a really good idea. It's a great way to organize your work. Now, how you find the vertex is you have to take this axis of symmetry, this 2, and plug it in for your x in your original equation that you're graphing. The reason why we're doing that is because the axis of symmetry is the very center of the parabola. That's going to be the dividing line going right down the middle. So that is the part where the parabola is going to be the same on both sides. The vertex is the very middle point of the parabola. So since the vertex is the very middle point of the parabola, it has to be on the axis of symmetry, which is the line in the very middle of the parabola. So what we're going to do is we're going to take this number and plug it in here. So I'm going to go ahead and rewrite this equation, but instead of x, I'm going to put parentheses. So this is y equals x squared minus 4x minus 5. You see what I did there? I took this equation and instead of x's, I put parentheses. Here's an x and here's an x. And the reason why is because I'm going to plug in this value in for x. Please make sure you're very careful when you simplify. 2 squared is going to give you 4. Minus 4 times 2, that's -8. Minus 5. This simplifies right here. We have 4 minus 8 is -4. Minus 5 is -9. So this is not the vertex. The vertex is your x value and your y value together as a coordinate point. So it's 2, -9. This is your vertex. So actually, if I count here, over 2, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to go kind of off the graph here. It's okay as long as we do a good job estimating. So the vertex is actually right here. If you want to label that V, you can. I recommend it just because it may help you later on in the future. So the next thing that we have looked for in the notes before is the y-intercept. The y-intercept is represented by the variable c, and we've actually already found that. So c equals -5, that is the y-intercept. Sorry, I'm having a hard time drawing those negatives there, those dashes. So what that means is the y-intercept is a point on the graph that crosses through the y-axis. So at -5, 1, 2, 3, 4, 5, right here, that is where the graph crosses the y-axis. That's the y-intercept. Now, here's something cool about this axis of symmetry, and this is why I like graphing it. You can use the property of symmetry to go ahead and find another point right away. So this is the very middle of the graph. This point is 2 points away from the axis of symmetry. So if this is 2 points away here, there should be another point exactly 2 points away on the other side. And I'm going to go ahead and label that as like a little star, just so I know, hey, I found this by using symmetry. It's just a little way that I use to help me. So last but not least, we have to find, I'm requiring my students to find a minimum of 5 points on the parabola. So we have to go ahead and find 2 more points, because here's 1 point, 2 points, 3 points. So I need 2 more points. Now a couple people have pointed out to me, hey, I can just find 1 more point, like let's say I find a point over here. I can use the property of symmetry to go ahead and plot one on the other side. That's great. In order to find one of these points, I usually like to make a little table. I'm going to go ahead and squeeze the table in right here. This is my x value, this is my y value, and in the middle what I'm going to do is I'm going to go ahead and show my work here, because I'm plugging it in here in order to find y. So this is x squared minus 4x minus 5. So in order to find a good number to plug in for x here, it's really up to you. You can pick any number you want. Some numbers are easier than others, but I like to choose a number that's close to the axis of symmetry, as close as possible, because then you're going to get the smaller numbers that are a little bit easier. So the number that's closest to here is either 1 or 3. I like to go with smaller numbers. It doesn't really matter. You're going to get the same answer, but I'm going to go ahead and plug in 1. So x equals 1. At this point, we don't have a point. So I'm going to go ahead and plug in 1. So I get 1 squared minus 4 times 1 minus 5. This gives me 1 minus 4. That's a minus 5. I know the work is kind of hard to see. Please bear with me. So 1 minus 4 is negative 3. Minus 5 is negative 8. So the other point on this parabola is 1, negative 8. So I'm going to go over 1 from the origin, down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm still running outside the graph. That's okay. That's okay. So I'm going to have a point that is symmetrical that goes over the axis of symmetry. I can go ahead and put that as a little star. And now I officially have 5 points on my parabola, so I can go ahead and graph it. Remember, a parabola is a U shape, so we're going to graph it as a U. And I will post this directly on Edmodo. Please reply if you have any questions.